Section 2.2, we're going to talk about biconditionals and what makes a good definition. So in the last lesson, we learned what a conditional was and what its converse was. A biconditional is a statement that you get by combining a conditional and its converse into one statement. We use the phrase if and only if instead of if and then. The shorthand version is IFF. So instead of writing out if and only if you'd just like to write IFF, you certainly can. So let's talk about how we take conditionals and turn them into biconditionals. So here is a biconditional that says an angle is a right angle if and only if it measures 90 degrees. The first thing that we need to do is discuss what's our subject. Okay, what part of that sentence is, what are we talking about? And the answer would be that it's an angle. Okay, the angle is our subject. And then the next thing that we need to pick out are what are the two pieces of our sentence that we would use as the hypothesis and the conclusion. And that would be, it says an angle is a right angle, so that would be one piece. Excuse me. And the other one would be that it measures 90 degrees. That would be the second piece. Okay? So to take this biconditional and look at what it's made up of, we have an angle is a right angle. And then we have that it measures 90 degrees. Okay? If I put an if in front of the first part and a then in front of the other part, it makes a conditional statement. If an angle is a right angle, then it measures 90 degrees. What's the truth value of that statement? Well, if it's a right angle, then it does measure 90 degrees, so it's true. Okay? The converse of that, remember that we write the if and the then stay, and the subject stays. But then we switch the other two pieces for its converse. So we would say if an angle measures 90 degrees, then it's a right angle. Okay? That's short for right. Okay. So this would be a conditional, and this would be its converse. Is the converse true or false? Well, if an angle measures 90 degrees, then it's a right angle. That would be true. That's a true statement. Since they're both true, that's how come we were able to write it as a biconditional. The good thing about a biconditional is that, first of all, it's only one sentence, so you only have to write the hypothesis and the conclusion once. Another good thing about a biconditional is that it doesn't matter which one you put first. Okay? And then the last part is you don't have to keep writing if and then. You just write the if and only if part right in the middle. So you write your subject first, then you write one of your two pieces of information, either your hypothesis or conclusion. Then you write the if and only if, and then you write the other piece. That's how a biconditional is made. Those are the pieces of it. Okay? So why do we write biconditionals? Well, like I said, first of all, you only have to write one sentence instead of two. The other thing is you only write a biconditional if both the conditional and the converse are true. That's the only time you want to write it as a biconditional. If they're not both true, then it doesn't make any sense to write it as a biconditional. A lot of times you will use biconditionals as definitions. So if you are given a definition of a word and you're asking if it's a good definition, write it as a biconditional and then split it up into its two pieces, into the conditional and the converse. If both are true, then it was written as a good biconditional and it's a good definition. If they're not both true, then it's not a good biconditional, it shouldn't have been written, and the definition is not good. Okay? So let's try using what we've learned about biconditionals, conditionals, and converses to see if a definition is good. Okay, so here's the example. Is the following a good definition? An apple is a fruit that contains seeds. Okay, well, the first thing we're going to do is write it as a conditional. So we're going to put in the words if and then. We're going to talk about the subject. What is the subject? We're talking about fruit. So that goes by the if. And then you have to identify the two pieces. Okay, well, one part is it's an apple. The other part is it contains seeds. So we'll say if a fruit is an apple, then it contains seeds. Okay, is that a true statement? Is that a good conditional? Does it have a true truth value? And yeah, if it's an apple, it contains seeds. So yep, that's true. So now we want to write it the other way. And if it's true both ways, then we'll rewrite it as a biconditional and it's a good definition. If they're not both true, then we won't write it as a biconditional and it's not a good definition. Okay, so to write the converse, if a fruit, remember that the subject stays, contains seeds, because that's what's going to be the next part. Then it's an apple. Okay, so that's the converse of the top sentence. If a fruit contains seeds, then it's an apple. I think there's some counterexamples there. It could be, if it contains seeds, it could be a strawberry or an orange or a raspberry or, for that matter, any other fruit. So we would say that this one has a false truth value, and since not both of them are true, it would not make a good biconditional, and therefore it would not be a good definition. So is it a good definition? Nope. Let's try and write a good definition, and then we'll test it using what we just did. Okay, so a figure is a triangle, if and only if. Well, give it a shot. What do you have to have in order for it to be a triangle? Well, let's try something like a figure is a triangle if and only if it has, what should we say, 3 sides? Okay, or if it has only 3 sides, maybe. All right, so you write that. And then you test it. You say this statement, take out the if and only if, and write it as a conditional. If a figure is a triangle, then it has only 3 sides. Is that true? Yep, that's true. Okay, now you write the conditional. If a figure has only 3 sides, is it a triangle? And now your trick is, can you find a counterexample? Okay, is that one true or false? If a figure has only 3 sides, then it's a triangle. Well, you might have to think outside the box on this one. Okay, if it only has 3 sides, what if it looks like this? That only has 3 sides. Is that a triangle? Or what if it looks like that? It might only have 3 sides, but it might have an arc on it. Okay, so we did not get specific enough, so that one's false. So therefore, it would not be a good biconditional. You're going to have to include something about it being a closed figure with only 3 sides or something to that effect. The symbols for biconditionals, we learned the symbols for conditional. This one says if P, then Q. That would be going one way. Its converse would be if Q, then P. And we know that if both are true, then we can write it as a biconditional. And in that case, notice that the arrow changes from only one side to now it has two sides on its arrow. So this says P if and only if Q. That's how we say that one. Okay, so these represent conditionals, and then the one with two arrow represents a biconditional because both of these were true. That concludes this lesson, and there is the homework.